The goal is to verify that this is a trigonometric identity. I'm going to start on the left-hand side and try and make it look like the right, because there's just not a whole lot I can do with cosine theta to make it more complicated than that. So let's see. On the left, I have two separate terms. Here I have one, and I have this lovely fraction. So one thing we can do is combine them into one term, which will need a common denominator in order to do that. So if I multiply my 1 top and bottom by the denominator, 1 plus cosine theta, then I'll have two things that we can add together with a common denominator. So on the top now I have 1 plus cosine theta, and then minus the sine squared theta that was up there already, over our common denominator. Okay, I guess that's good. I'm down to one term instead of two. I'm going to notice that what I'm aiming for is just cosine theta, and I got this sine squared in here, so I would like to do something to make that into cosines instead of sines. The good news is there's an identity for that. We know sine squared theta plus cosine squared theta is 1. So I can rewrite sine squared theta as 1 minus cosine squared theta, carefully since we're subtracting. If you distribute that negative through immediately, that's fine. I tend to have better success if I do it one thing at a time. Now let's go ahead and distribute that negative through and see what we have on the top. I'm going to have minus minus is plus cosine squared theta. And there's negative 1 to go with my positive 1 over here. Those are gone. Negative 1 plus 1 adds up to 0. Those are gone. But I do still have a cosine theta. And the denominator hasn't changed. It may be tempting to do something like just cross out the cosine on the top and the cosine on the bottom and call it cosine squared theta over 1. Please don't give in to that temptation. This denominator is a unit because of that plus sign in the middle. I can divide away all of it or none of it, but not part of it. So where does that leave us? Well, we have all cosines. That's good. Next thing, I have two terms on the top that both have a cosine in them. So let's factor out a cosine. When we do that, from the first term, I have left a cosine. From the second term, I have left 1. Denominator, still there. Now, couldn't do this before, but now I have cosine theta plus 1 on the top, cosine theta plus 1 on the bottom. Well, it's 1 plus cosine theta, but addition's commutative. The order doesn't matter. Same thing, top and bottom. Now we can divide. Couldn't before. Now we can. Those are gone. And all I have left is cosine theta, which is good because that's what I was hoping for. And we've just shown that that equation is an identity.